Guys, it's Miss Landry, and we're going to learn about two macromolecules in this video. So this is lesson 3.3. We're going to learn about carbohydrates and lipids. So carbohydrates, as you know, are used for energy. So this is basically sugar, and sugar is the monomer, which we're going to go over. And then, of course, we're also going to learn about lipids. So we're going to learn about fats, oils, phospholipids, steroids, and waxes. So let's jump right in. So starting with carbohydrates. Remember, I asked you for all of your macromolecules, I want you to know the monomer, the polymer, examples, and also the function. So let's start with carbohydrates. So carbs are, unfortunately, my favorite food. They are made of sugar, and anytime you see a chemical word that ends in the suffix ose, O-S-E, chances are it's a sugar. So the monomer of a carbohydrate can either be a monosaccharide or a disaccharide. Don't get scared by this, okay? Mono means what? It means one, beep. And saccharide is actually Latin for sweet, so sugar. Examples of that would be like glucose and fructose. A disaccharide, di, this prefix means two. So this is going to be a sugar that has two carbon rings. So if you look at these pictures, here's glucose. Notice it has a single ring structure, right? So this is a monosaccharide because it has one ring, one carbon ring. Okay, so that's a monosaccharide. That is an example of a monomer. And then here is maltose. Notice again, it ends in ose, so it's a sugar, but this one has two rings. So this would be considered a disaccharide. Both of these are monomers of carbohydrates. Okay, so the key when you're looking to see and identify the macromolecule, if you see these rings like this in a chain, it is a carbohydrate. So always look for that. It's kind of a key way to find it. So now let's talk about the polymers. I want you to know a couple different polymers of carbohydrates. Starch, cellulose, something called chitin or chitin, depending on how you want to say it. And then there's a fourth one, which is glycogen. So these are called polysaccharides. Remember, the prefix poly means many, and saccharide, again, means sweet or sugar. In regular worlds, not science worlds, we actually call these complex carbohydrates. So if you look at it, they're usually found in different shapes. So let's start with starch. Okay, so an example of starch would be like potatoes or pasta. And if you notice, all of these little tiny circles on here that are creating this branch structure are glucose. So the single little circle in all of this, so if I were to like 1, 2, 3, you could count them if you want, but I don't want to. Those are all glucose. So those are the monomers, and they're chained together to create this polymer called starch, which is a polysaccharide. Glycogen is very similar to starch, except it's more highly branched. Okay, so you can see all these extra branches. This is how we actually store glucose in the body. So eventually, if we have too much glucose, this is where weight gain can happen, is in the storage of glycogen in the fat cells. And then finally, we have cellulose, which if you look at it right here, it has a very different structure. It's still single units of glucose, but it's stacked in a way that our bodies cannot digest. So we actually call this dietary fiber. So like when you eat celery, for example, the crunch and the fiber that you can't digest of celery is this right here. It's cellulose. Kind of cool. And then finally, we have chitin, which is actually found in the exoskeleton of insects. So if you eat insects, you're actually getting carbohydrates. Of course, a little bit of protein, which we'll talk about later. Chitin's a little bit different than these other polymers because it also contains nitrogen. So chitin, though, if you can never remember anything, just picture yourself crunching on a cricket like this and going, chitin. That is also a carbohydrate. So I thought you'd find that interesting. Okay, so that is carbohydrates. Let's review that real quick. The functions. Let's talk about the functions first. We all know that the function of carbohydrates is for energy. Okay, so simple sugars like glucose, fructose, which is the sugar found in fruit, those are for really quick energy. So if you were to drink a Mountain Dew, right, it's got a ton of sugar in it. Okay, that sugar is going to be burned off pretty quick. So I'll try to make a flame there. Doesn't really, looks more like a, I don't know what, a crown. But if you eat a complex carb, like let's say I had a bowl of pasta, your body's going to break down that starch into a simple sugar. It's going to go into my bloodstream. If I don't use that sugar right away, it'll be sent to the body cells through insulin, the signal of insulin. And if it's not used as fuel, like if I don't work out at all, it's going to be stored and later used as fat. So energy is key when it comes to carbohydrates. That is its main function. Okay, review. Pause the video, answer these 4 questions. The first one is, what is the monomer of a carbohydrate? Number 2, give 2 examples of polysaccharides or polymers of carbs. True or false, we cannot digest chitin, but we can digest cellulose. And then finally, true or false, starch is a long chain of sugars. So go ahead and pause the video, answer those questions. Okay, so a monomer of carbohydrates can either be a monosaccharide or a disaccharide. I would also take the names of the sugars. So I would take glucose, fructose, maltose, lactose, any of the sugars. But remember, mono and disaccharides are the monomers, simple sugars. 2 examples of polysaccharides would be, well, I'll give you all 4. Starch, glycogen, cellulose, and chitin. So those are examples of polymers or polysaccharides. And then true or false, we cannot digest chitin, but we can digest cellulose. This is actually false. It's the opposite. We cannot digest cellulose, but we can digest chitin. And then finally, true or false, starch is a long chain of sugars. This is absolutely true. That is basically the definition of a complex carbohydrate. So, okay, that's it for carbohydrates. Now let's move on to lipids. This is the last thing we're going to talk about on this video. Lipids don't really have a monomer and polymer structure. So this is kind of its own little category. So I'm not going to ask you to know the monomers. I am going to ask you know specifically a couple things. So I'll go over it real quick with you. What I would like you to know about lipids is that there are 3 types. So these are fats and oils and things like that. The first type is called a triglyceride. It's named a triglyceride because it has a shape with 3 of these tails. These tails are called fatty acids. Okay, and so those 3 tails make up the name tri, which is 3, and then glyceride. These are the fats, okay, or the oils. So if it's a saturated fat, it will be solid at room temperature. So that would be like butter, something we all love, right? Versus an unsaturated fat would be liquid at room temperature. And you've probably heard in terms of health, it's better to eat more unsaturated fats than it is to eat saturated fats. So keep that in mind. Just you do need to know the difference between saturated and unsaturated fats. Lipids do make up the building blocks of steroids, which is kind of important, and waxes in your body. The one I really want you to know is this one right here, phospholipids. When we get into the cell membrane structure, it's going to be really important. So this is what a phospholipid looks like. Okay, it has what's called a hydrophilic head and a hydrophobic tail. If you notice, it's got 2 tails. Those are fatty acids, just like in the triglyceride here. We could almost call this a diglyceride, but it's actually called a phospholipid. So let's take a look at phospholipids in more detail. So like I said, it has this head that's a phosphate, and phosphate is P, so it's phosphorus surrounded by 4 oxygen. Doot, doot, doot. Those oxygen give it a pretty good negative charge, so that means it's going to be attracted to the partial positive of hydrogen in water. So this is hydrophilic. It loves water. Philic means love. Hydro means water. The 2 fatty acid tails, on the other hand, down here at the bottom, they actually hate water. They're afraid of water. So Ew, we'll put a little heart with a little slash through it. They do not like water. So this property is actually called amphipathic. You've probably heard of somebody being ambidextrous. This is kind of like that. Amphipathic means it has both a hydrophobic and a hydrophilic portion, which this does. When two of them are together, these two hydrophobic tails are going to come together and create like this inner chamber that is against water. It doesn't want water in there. Whereas the outsides of the phosphate heads, they love water. So this is what actually creates the phospholipid bilayer of the cell membrane. So that's a picture of the cell membrane. Let me clear out my coloring here and I'll show you. So if this were a cell, I would draw this cell kind of like this, right? Here's extracellular. So this would be outside of the cell and this would be inside the cell. So that's kind of cool. So fats are very important. Lipids are very important in your diet because they make up cells. Review real quick. Let's do this super quick. Pause the video, answer these. What are 3 types of lipids? True or false? Unsaturated fats are liquid at room temperature. What is the structure of a phospholipid? And then finally, what is it about the phospholipid that makes it amphipathic? Answer those questions. Come on back. All right, so the 3 types of lipids we talked about were, we talked about triglycerides, we talked about steroids and waxes, and then finally we talked about phospholipids. True or false? Unsaturated fats are liquid at room temperature. That is true. It is the saturated fats that are solid at room temperature. What is the structure of a phospholipid? It has a phosphate head and 2 fatty acid tails, just like that. And what is it about it that makes it amphipathic? The head loves water. It's hydrophilic. The tails don't like water, hydrophobic, and that's what makes it amphipathic. All right, that's it for this video, I believe. Yeah, so I'll see you guys in class. Thanks, everybody.